We'll attempt here to prove the convolution theorem. The convolution theorem states simply that the convolution of two signals in the time domain corresponds in the frequency domain to the product of the two spectra. So convolution in time domain, multiplication in the time domain, in the frequency domain, sorry. And we're going to try to prove that by replacing this arrow with an equal sign and carrying out the Fourier transform. So the Fourier transform is simply an integral from minus infinity to infinity multiplied by e to the minus j omega t dt. And the convolution is itself another integral from minus infinity to infinity, f of tau g of t minus tau d tau. So let's bring that down a little bit. There. So here we have f of tau, we've got d tau. So it would make sense if I were to switch the order of these integrations, just to keep the taus on the outside. And I could also apply a change of variable here. I could say something like, let u equals t minus tau. So this t would be u plus tau. So I can now rewrite the integration as something like this. I'll leave out the limits for now, just to keep it simple. And I say f of tau multiplied by e to the minus j omega tau multiplied by, I can actually remove that integral and bring it here. And here I'd have g of u times e to the minus j omega u du. And if you look carefully, that is the definition of the Fourier transform of f, and this is the definition of the Fourier transform of g. So this is simply f of omega, and this is g of omega, and between them we have a multiplication sign. So I've just shown that the Fourier transform of a product of two signals corresponds, the Fourier transform of the convolution of two signals corresponds to the product of the two spectra. So that is the convolution theorem, or the convolution property of the Fourier transform. So that would be your final answer. That's how you would present the proof. And the proof of the inverse would be very similar. It's simply two integrations and a change of variable.